Hi, I'm Bob Henry with Epilog Laser. Thank you for joining us today for this Global Spec webinar. We're really excited to show you our G2 Galvo-based laser marking system. Today we're going to process a variety of different materials with the machine. Through that laser processing, we're going to show you the functionality and the capabilities of the laser system. We're also going to show you the control panel on the laser, and we're going to spend a fair amount of time in our dashboard, print driver, and job manager software. First, before we get started with marking, I want to talk a little bit about laser beam delivery and about laser sources that we're using in the G2. Typical Galvo systems have a laser beam that's directed into high-speed motors with mirrors attached. The mirrors direct that laser beam down to the work surface. Galvos are known to be very fast and very efficient at high-speed marking. The drawback to a Galvo is they typically have a very small marking area. With the Epilog G2, we're using a 3-axis Galvo with a translator optic in here. The translator optic has a dynamic adjustment that compensates for beam diameter as we're marking over a much larger area. So with the G2, we've identified and described 3 different marking fields in the machine. We have near field, which gives us a 4x4 area, midfield, which is a 16-inch area, and then in far field, a 24-inch area. Big advantage for a lot of our customers that are doing multi-part marking or large pieces that they want to mark as well. We'll go over that a little bit more as we're going along with the demonstration. Also, in regards to laser sources, we're using 2 different types of lasers. We have a Q-switch laser and a MOPA laser. A Q-switch gives us a fixed pulse length, limited frequency ranges, typically used for deep engraving or surface marking. It's going to offer our customers a little bit lower price. The MOPA laser is master oscillator, power amplifier, gives us a variable pulse length laser, greater frequency ranges, essentially more knobs to turn to produce different types of marks on the metal. More used for finer control on metal marking and engraving, enhanced plastic marking, and in some cases, nice colors on different types of metals. So with that, let's get started with marking some metals. We're going to jump into the software suite, set up some jobs to run in the laser, and we'll get started right now. Before we get started processing materials, I'd like to spend a little bit of time on the control panel of the laser system. Power switch on the right-hand side. The first thing you notice when we turn the laser on is that we've got a nice lighted cabinet in the machine. We can toggle that on and off. Sometimes it helps with the red diode pointer for locating focus and also tracing where you're going to mark on a part to turn the laser, the cabinet light off. Just provides for a little bit better view of the red diode pointer. At the control panel, you can see we've got a variety of different buttons here. It's all symbol-based information here. This is our jobs list. We don't have any jobs in here currently, but if we had sent multiple jobs over, we could push this button and then scroll through and select the job that we want to run. This is our focus feature. Right now, we have the laser system set in the midfield, so this provides us with a 16-inch by 16-inch marking field. Currently, the table is sitting at about 25 millimeters higher than the ideal focus range in this machine. This button is pretty neat down here. These describe the different fields that we're working in. If we wanted to mark in near field, we simply push and hold this button. You'll notice that we get a moving translator here. And now you see that we're 238 millimeters off. So in this case, we would want to raise the table up until it's at a 0 focus. Then we're in the ideal focus range. If we switch back to midfield, which is what we're going to use for our first engraving marking that we do today, you notice that I press and hold this button, and this brings us to a 0 focus in that location. Same thing would apply here for far field. If we wanted to move to the far field, we'd push this once. The translator moves within the Galvo device, and then if we press and hold this, the table would go all the way down to read a 0 focus, then it would be in the ideal focal range for that location. But we're just going to switch back to midfield marking for now. This button is a start and pause button while you're running a job. To start a job, you push this button, that starts it, and then to pause it, you press it again. That will pause the job. If you repress the go button, it will start up right back where we left off. This would be a reset button. If you started the job and you want to stop that job in process, you could hit this and that will reset the button, reset the job. This is our trace function. So when we're running a job, we want to make sure that we're going to be marking in the correct location. We press this button and that provides a red box around the location of where we're going to be marking. Really handy for making sure that you're marking in the right location. And then lastly, this is the tools button here. This is where we set the IP address for the machine. I should point out that all Epilog laser systems, including the G2, can operate through either a USB connection or a network connection. Network connection is really favorable with a lot of our customers. They may have 2 or 3 or 4 flatbed lasers running through a network. They can simply hook this up, just establish a new IP address for the G2, and direct different laser jobs to all of those different laser systems through the different IP addresses. So in here we set all of the parameters, all of the base settings for this machine. So a little bit about the control panel there. Inside you'll notice that we have, in the back of the machine, we've got louvers that allow us to close and open different regions on the table. If we're marking in near field, for instance, we could close this louver, open this one. This allows the particulates, the vapors that created during the marking process to be efficiently removed from the laser system cabinet. So we've got louvers for all 3 different marking fields. We'll open that one because we're going to be working in the midfield today. Also with this machine, we've got different edge guides that we can use. Right now I've got the edge guide set at this location. This would correspond to the 1616 marking field. If we're working in the 4x4 marking field, we would set the edge guides right there. What's unique about the G2 as well is that we're working on an XY0 coordinate system. Much like our flatbed lasers, where these two intersect is the 0, 0 position on the table. This would correspond to the upper left corner of the graphic page that you've set up. So really intuitive for a lot of our customers that are used to that type of setup. If we're marking in far field, we would simply move the edge guides out to this location. And then again, this upper left corner would correspond to the upper left corner of that 24x24 space. So just a little preview on the control panel and then inside the laser system. Let's move now over to the artwork side and the software suite, and we'll show you how we set up a job to run in the G2. The first graphic they're going to work on today is just a simple engineering drawing for a building. This is on a 12x12 space here, so we're going to use the 16x16 marking field for this example. You'll notice in this graphic that this is all outline information here. So we have the ability in the G2 to do outline marking by setting a line width to 3/1000 inch or less. This is just going to simply produce an outline over all this graphic that you see here. Later we're going to be doing some marking where we're using filled areas to produce, of course, a different type of effect, but this is going to be a very high-speed mark. Once we've got the graphic constructed, again, this is we're just using Corel Draw for our work here. The G2 is compatible with a variety of different softwares. A lot of our customers will use Adobe Illustrator or InDesign, AutoCAD, SolidWorks, Bartender, Engraved Lab, a variety of different software packages work with our G2 laser system, much like they do all of our laser systems. So we feel like this is going to be a big advantage to a lot of our customers. The ability to use whatever software that they like and they're used to, instead of having to use the proprietary software that is typical with most Galvo-based systems. So once we've got the graphic created here, we simply go to File and then Print. And you'll notice when we click on the Print button, we have different lasers that we can select from here. You can see a bunch of different output devices. We're going to select the Epilog engraver, and then once we've selected that, we go to OK. And here we see our dashboard being populated on the screen here. In the dashboard is where we set all the laser parameters for this particular job. I'm going to spend a little time in here just explaining what we're seeing, and then we'll process this job, and then we'll move on to the next one, and we're going to use more functionality in this. So the name up here, CA Signs, this is the job title. We can change this if we wanted to in the dashboard. Autofocus on or off. If we wanted to autofocus on this particular material, we know that this thing is, the material that we're going to use, just some sheet stock anodized aluminum, is about 0.6 inches thick, so we can program that as well. For now though, I'm just going to do a manual focus on here. I'll show you how we do that. We'll do some autofocus with some of the other work that we're going to be doing here in a little bit. So for all of our work in the G2, we select the hatch raster type. Here I'm going to select vector on with the graphic that we've got right now. We want to run this in this mode where we're using this vector function. This allows us to do any sort of vector marking that is line width of 3,000ths inch or less. If we're going to be doing filled marking, we'll be using these functions down here. I'm going to go over that with some of the samples we've got coming up. So I'm just going to get rid of this for now. And here we're only working with vector. So in this mode, I can set the speed to whatever I want. I know on this particular material, I can do a very high speed mark. I'm going to set the power high as well. And the frequency value, I'm going to set high as well. The pulse range, I'm going to set to maximum at 7. The pulsing values with the G2 range from 0 to 7. 7 gives us more energy to be ablating the material on the anodized. And once we've got all of these set, I simply click Send to Job Manager. And then the Job Manager pops up, and you can see there it is. The Job Manager basically stores all of the jobs that we've sent over to, that we're planning to send over to the laser. What's nice about the Job Manager is that you can come back in here into the manager without opening your graphic software and reprint that job from the Job Manager. Also, some features in the Job Manager, really nice. You can open it up. You can change different things. If we wanted to maybe set the power to 80% here, we could do that and save that. And if we wanted to do a couple passes, maybe we'll do 2 passes on this to get a little bit more depth into the material. We can program that as well. So once we've got that set, I can click on Save, and then here I just click on the Print button in the Job Manager, and the job is transferred over to the laser. So here's my material that we're going to use. Again, just sheet stock anodized aluminum, some industrial signage piece that we're working on. I mentioned the edge guides that go in here. So with the 12 by 12 piece, again, the upper left corner of my graphic page corresponds to the upper left corner on the edge guides there. So this is the proper location for where we want to mark. At the control panel of the laser, I'll want to adjust the focus so we have the right distance. We want to lower the table to accommodate for or account for the thickness of this material to be in the right focal plane. So I'll press the focus button, and then I'm just going to lower this down to 0.6 millimeter, which I know is the height of that material, or rather the thickness of that material. Perfect. And then I'll press on the Jobs button. There's our sign, our CA Signs job that came through. The name of the graphic file, as we've given it in the software, shows up here on our LCD, our display panel. Once we've got that set, the focus is good, we can then start the job. So we'll turn the camera over to the machine, and then we'll let this thing run. So you'll notice the second pass is going over the exact same location. This is going to provide a little bit more depth into the material for more permanence, or in some cases it'll brighten up the mark as well to give you more contrast. So that was about 16 seconds per run, so about 32 seconds for the total job time. I'm just going to tip this up so you can see it. We've got a nice mark there on the material, very permanent, some nice depth into the material as well. Now let's move on to the next job. The next job that we're going to process in the G2 laser are some heat sinks, typical industrial marking application on just bare aluminum material. So first thing you notice in the Corel Draw setup here is that I've got a 16 by 16 page size. I've measured the size of the heat sinks. They're about 3.2 in size. And then I've populated those across the entire page, fit as many as I can into this space. So I'll zoom in on this. You can see that we're going to put this little mark indicator on the back side of the heat sink. With the G2, of course, we can load up as many parts in this 16 by 16 space that will fit. For this example, we're just going to run the top row of this symbol on the different heat sinks. So I'm going to select those, and then I go to our dashboard print driver. Here in the print dialog, I'll select selection only. That means we're just going to run the ones at the top of the page there. And then here I click OK. This brings up our dashboard print driver. This is a great feature. Again, this is where we can set all the laser parameters for this particular job. What we're going to do with this material is set some different laser parameters. We don't have any vector or thin line art that we're going to use in here, so I'm just going to deselect this. This is where we can set different hatching patterns for the work that we're going to do. So for this particular material, I know that I can run about 75 speed, 100 power. I'm going to set the frequency to 100 as well. And then I want a lot of pulsing energy, so I'm going to set this to 7. Here we can also set different line spacing. I'll maybe set this to 0.15, 0015, so it'd be 1.5 thousandths spacing between the lines, so we'll have a nice deep engraving into those areas. The wider we set that, of course, the farther apart the lines are. In some applications, that's advantageous to have a wider line spacing. For this anodized aluminum, or rather this bare aluminum, we'll just use that 0.15 thousandths or 1.5 thousandths. And here we can set the angle at which we want the laser beam to work on the material. So we'll set this at a 45-degree angle, and then we're going to do just one pass on that. I'm going to add a second pass opposite of 45 to get a little more depth into the material, create a little more permanence into that mark. So with that, I could just add a new hatch pattern. You'll see that I've got hatching pattern 2 here. With this, I want to set the same laser parameters, so I'll go to 100 or 75 speed, 100 power, 100 frequency, and then pulse value of 7 again. With this, I'm going to set it at 315 angle, so we're kind of working at opposite angles with the mark there. It tends to remove more material a little bit more efficiently, and then we'll do one pass on that as well. And then I'm going to use this feature. This is called our open or closed hatch. If we use open hatch, it's going to do one item at a time. Rather than having closed hatch where the Galvo, the laser beam, is sweeping across the entire workspace, this is going to be a little bit more efficient to do with an open hatch here. So once I've got those laser parameters set, I can send it to the job manager, which I typically do, or I can print it directly to the laser. In this case, I'm going to send it to the job manager. Back to the job manager, you'll see the last job that we just ran there. Here's the new job that we just sent over for the heat sinks. And then I'm just going to review my jobs here. I should point out one more feature here, and this function here might be a little bit difficult to see, but we have the ability to control how we're directing the laser beam. This is what we call S sweep. In this case, the laser is on as it's moving in all directions. With the open sweep or standard sweep, the laser is on as it's moving in one particular angle, and then it turns off slightly as it moves down to the next line. And then this would be a unidirectional type of mark. This would be an outline mark, so if we just wanted to do an outline of that graphic that we've created, we could select this one. For this example, though, we're going to use the S sweep for both of those 2 different passes. So we can toggle through that and select those. Once we've got all that set, we can hit the Save button and then print the job over. So the job is sent over to the laser system. Let's turn our attention over there, and we'll get this thing ready to run. So the first thing I'm going to do is just nest my parts up in the upper left corner. Again, if I was going to do the entire batch, I could just continue to place them in here, and the laser would do all of those at the same time. I also need to make sure that I've got my focus set correctly. So I'm going to adjust the focus at the control panel on the laser. The control panel on the laser is set in metric right now. You can switch that to inches or metric, whatever you prefer. So the height of that heat sink is 30 millimeters. So I'm going to go to the focus button, and then I'm going to bring the table down to 30 millimeters, and then we'll start the marking. Okay, once we've got the proper focal distance set, we close the doors. Notice on the front door of the G2 laser system, we've got some really big viewing panels on here. You'll also notice it's got a green tint to it. There's an organic dye in this Lexan material that absorbs the light energy, so there's no way for the laser beam to escape the cabinet. This is a really important, especially for this wavelength of light. that you have a fully interlocked, fully safe machine for operation. So once we've got that set up, the focus is good, I go to the control panel, select the Jobs button, and then I can start the job. So there's the first pass on each of the parts, and when this is done, it'll come back and do the second pass at the opposite angle. Again, this second pass has given us a little bit more depth into the material. And depending on what your requirements are, you may do multiple passes in many different hatching angles to get more depth. So there's the mark. Nice clean mark, very permanent. Okay, let's move on to the next job. The next group of parts that we're going to work on are some gun magazine floor plates. You'll notice in the video that we've got a template built. I created this jig that fits the parts nicely. This is a 12 by 12 inch setup. When we're ready to process, I'll put that up in the upper left corner. Again, everything is based on the upper left corner of the graphic image that we're working on here, as well, where those edge guides come together in the upper left corner. Really easy to set jobs up this way. So here, again, I've got the graphic set up. I'm just going to put a part number on those floor plates. So for this example, I'm just going to select a group of those to engrave or to mark with the laser. This is anodized aluminum. This will be a fairly quick mark. So once I, again, have selected the parts that I want to mark, I go to the Job Manager dashboard for the Epilog Laser. And here I can set all the laser parameters for this particular job. First, again, hatch pattern is what we're going to use. We're going to use an open hatch as well. We're going to do one pass on this, and I'm going to use our autofocus feature built into the machine where I can just change the table height. I know that the height of that material is 0.52 inches, and with this particular material I can run very high speed, and I'm going to go lower power. I'm still going to use 100% frequency and a pulse value of 7. And I'm going to use an angle of 90 going from left to right. The way the artwork is set up, it makes sense to go left to right. It'll save maybe a few seconds on this particular job. And then again, I'm going to use the fastest marking that we have here, the S sweep. You'll notice I don't have another hatching option here, so we're just going to run this with one pass. So once we've got all those laser parameters set, I'm going to hit Send to Job Manager. I like to use the Job Manager. Again, if I send jobs over to the manager, I can recall them later, bring them up and run them again at a later point in time. Also, if I wanted to change those laser parameters, I could come back into the manager and do that here. So we've got this set. We're using autofocus. I'm going to click on the Print button, and then we'll go over to the laser and get this set up to run. First thing I'm going to do is check the focus. We're out a little bit, that's okay. So I'm just going to nest my parts up in here and then close the door. And then when I start this job, you'll notice the table is going to move slightly to the correct focal plane based on the numbers that we programmed into the Job Manager. So I'm ready to select my job. There it is. And then I'll just click on the Start button. There was a slight movement of the table there coming up to the right focal plane, and you'll notice that the parts are all marking. That was 6 seconds to mark those parts. You'll notice we've got a really nice bright white mark on that anodized aluminum. Okay, let's move on to the next job. The next part that we're going to mark is a motorcycle cylinder head. For this piece, we've moved the table into the lower position. This would be the far field marking area. One thing I want to point out is the size of parts that you can place in the laser, depending on which field you're marking in. In far field, the 24-inch marking area here, we're able to accommodate parts that are almost 16 inches in height. In midfield, the 16-inch marking area, we can go up to just at 26 inches in height. And then in near field, the 4-inch marking area, we can actually accommodate parts that are just over 36 inches in height. So yeah, large capacity in the machine for different height parts. So I've got a graphic all set up here. You can see we're doing a custom logo on this cylinder head. So the first thing I do is print it over to the dashboard. And then here, I'm just going to send this to the Job Manager. We're going to do a little bit something different with here. We're going to pull information from a library that we've already set up in the job manager. So I'm just going to send this over to the manager. I'm going to double click on this. You can see that we've got a base parameter already set up in here. I'm just going to discard that. And then I'm going to go to this import function here. And then I'm going to go to the different categories I've got set up. We're working on cast aluminum, so I'll select that. And I've got a subfolder set up for single cylinder. There's all my laser parameters for that job. If I double click that, it automatically populates my job manager with all of those laser parameters. So what we've got with this is we're running all of the parameters the same: 75 speed, 100 power, 100 frequency, and a 7 pulse value. You can see that I'm coming in at an angle of 0, and then we're going to come in at 90 degrees, and then also at 45 degrees, and then at 315. Cast irons or cast aluminum is pretty hard to work with, pretty hard to ablate a lot of material. So we're going to come in with 4 different hatch patterns, and then we're going to do that 2 times to get a little bit more depth into the material. So once we've got all that set up, we can save that and then simply print it over to the laser. Once the job's at the laser, you can see that we've got it set up in the far field with this machine. A couple things I want to show you here. First, we have a focus finder built into the G2 laser. It's a red dot, a combination of red dots and a red line that when they line up, we're in the correct focal plane. Really handy feature when you're working with odd shaped parts and it's not easy to measure the height of that part. So what we do to find that is press and hold the focus button. You'll notice that we've got a red line and a red dot there. And then I'm going to raise the table up until the red spot intersects directly over the red line. Once those two intersect, we're in the correct focal plane. We can stop the table movement there, and we're ready to mark. Before we mark, however, I'm going to use the trace function in the Galvo to identify the location of where the mark is going to go. So on the control panel of the laser, I press the trace button, and you'll see we've got a red outline that shows the location where the mark is going to go. I'll turn the light off so you can see that a little bit better. With our part installed and correctly focused, and we've identified the marking location with the trace function here, I'm going to go ahead and turn the trace function off, turn the light on, I'll close the doors, and we'll start the marking. So again, this is going to go through 4 different hatch patterns. We're going to do it 2 times to get a little bit more depth into the material. While that's running, I'm going to talk a little bit about the power density of the laser beam relative to the field in which we're working. I've got a part that I'll show you. I'll just put it on the display panel here. You should be able to see in the 3 different field marks here, we've got some nice depth into those things. We ran all the same laser parameters for each of those different engravings. We had the same hatch patterns, the same number of passes, and the resultant time was the same for all of those as well. What you'll find with this, in near field we have a real deep marking, and midfield that's a little bit shallower, and then far field shallower yet. With this particular sample, the near field is 31,000 steep, midfield 27,000 steep, and far field is at 22,000 steep. So in near field, we're able to get more depth into the material for a given set of laser parameters as compared to the midfield and far field. So our customers, they're going to want to do real deep engraving. They're probably going to find it to be more time efficient to do it either in near field or midfield. But certainly we can get really good depth in far field as well. So we'll turn our attention back to the laser, and you can really hear it starting to rip through the metal now. We're getting some nice depth into it. Again, we're running a total of 8 passes on here, so we should get a pretty nice deep engraving into this cast aluminum. All right, the beep tone tells us the job is done. I'm just going to pull the part up here a little bit so we can take a look at that mark on there. A little bit of a bladed material on there. Use a soft bristle brush and that comes right off. But you can see we've got a nice permanent deep mark into that metal. Okay, we have one more project that we're going to do. So now let's move on to the next job. The last piece that we're going to process today is a wheel component. On the screen here you can see that we've included some specifications for this particular 22-inch wheel that we put in the G2 laser system. With this size, of course, we'll be marking in the 24-inch field. So this is all set up. We've got spec data on the top, left, bottom, and right side of the wheel. And so we'll print this over to the machine. We'll select those components that we want to mark, hit the print icon, and click OK. And then here, again, in the dashboard, we'll set the laser parameters. This is just a powder-coated material, so this is going to be pretty quick. We're going to do one pass at this, and then I'm going to apply 100 speed, maybe we'll have 75 power on this to get through that powder coating, frequency of 100, and I'm going to try a pulse value of 6. We'll come in at a 90-degree angle, and then, again, just the one pass, and we'll do an S, or rather an open sweep on this one. It'll be a little bit slower, but it should work pretty well. So we're ready to go. I'm going to send this over to the job manager. There's our job there. One thing I need to show you in the job manager is this preview function. This gives you the ability to look at this as well in the preview to make sure that you've got the right job and everything looks good in there. And we'll go back to our colors tab and we'll save that, and then we can print it over to the laser. So the job's arrived at the laser, and we'll close the doors and let this run. But we'll actually hit it with another pass and see if we can get that to brighten up. There we go. So it looks like 3 passes with this powder coating does a nice job to clean that up. So now we've marked the specifications for this wheel component all the way around that 22-inch diameter wheel. That concludes the marking for today. I'd like to do a quick summary before we jump into the question and answer session. So we've marked all the components with our new G2 laser system. You saw with the G2 that we're able to mark very large components, up to 24-inch size components. We can also mark in midfield at 16/16, and then also at near field, a 4-inch marking area. We're using non-proprietary software. In this case, we used CorelDRAW to create the graphic images. Again, you can use a variety of different software. What's really nice about our software suite is that once you send the job over to the laser, you're free to go back into the software and program your next job. A lot of Galvo-based systems with proprietary software tie up the resources of the computer and don't allow you to program the next job while the job is running. Also with the G2, we have network and USB connectivity, allowing our customers to use a variety of different Epilog systems on one computer. Also our XY coordinate systems using the edge guides in the machine allow for a really easy layout of the machines. We also did some single part marking, just using midfield for marking on the cylinder head. And then the availability of the different lasers in the machine, the Q switch or the MOPA, offers our customers a lot of options to do different things with different types of materials. Any kind of metal, engineered plastics, we have customers using it for ceramics as well. So with that, we really appreciate your time today. Thanks so much. If you have any materials or applications you'd like us to test, contact us directly at Epilog or visit our applications page on our website.